All right, in the last video, we took a look at some of the simpler or the smaller atoms and their electron arrangements. So in this video, what we're going to do is we're going to take a look at some of the more complicated ones, or some of the larger atoms. And so here is a breakdown of the first 18 elements. We can see here, and we did hydrogen, so we know it's 1s1, helium's 1s2. Lithium has 3 electrons, so it would be, so this is just the last electron in each atom would go where? So the last electron in lithium would go into s1, the last electron in beryllium would go into s2, and then you so on and so on and so on. We get to sodium, which is in the 3rd energy level, and we see that it is 3s1, 3s2, 3p1, 3p2, 3p3, and so on. Now what you might start to notice are some patterns. For example, the row that the element is in is the same as the number of the highest energy level of its last electron. So this is row 1, this is row 2, this is row 3. Whoops, that's bad. 3. This is row 3, right? So in row 3, the last electron will go into the 3rd energy level. In row 2, the last electron goes into the 2nd energy level, and so on. You might also notice that this first row will be S1, the second row S2, and then the 3rd row. Now, the transition metals are here, and we'll skip them for a reason. So the transition metals we're skipping just for now. And we'll talk about that in about a minute. And once you skip the transition metals, you get here, and you can see that this is P1, P2, P3, P4, P5, P6. Well, these sections of the periodic table have a name. And it was this periodicity, or this kind of repeating of a pattern, that Mendeleev used to arrange the periodic table. You see, the elements in a periodic table are in families because they share certain characteristics with the other elements in their family. And you can see that all the elements in family 1 have their last electron as s1, and so on. And this was a powerful clue into the behavior of the atoms, and Mendeleev had no idea that the electron arrangements would end up this way, but they did, and it just further verified his theory and his idea of the periodic table. So now let's take a look, do one. It's a little bit more complicated. So let's take a look here. We have the periodic table, and I told you that the different sections of the periodic table have names, and the names will actually tell you what sublevel is used to fill up the last electron, to put the last electron in each case. And so we see the first 2 columns here. So we're looking at these 2 columns. These are what are known as the S block. So these are the S block elements. Okay? And you can see here the transition metals are what are known as the D transition metals. I call this the D block. Or I don't call it that. Chemists call it that. I just do what they do because it's been done that way for many years, and we need to be able to have a common language to communicate. And so we call it the D block. This is called the P block. And then all the way down here, this part of the periodic table, these are known as the F block. Elements. And just for so you know, these F block elements should go right here in the periodic table. They actually should fit there. The reason that they're down there is an aesthetic reason. It's only so the periodic table fits nicely in a book or on a rectangular piece of paper, because if those F block elements, these F block elements, were placed into the periodic table here, the periodic table would bulge out on these ends, and it wouldn't be a perfect square as it is now. And so what they did is they moved them down here, and then it became square and easier to fit on paper. That's it. That's it. So I'm going to teach you how to use the periodic table to write electron configurations. It's a little shortcut that makes life a lot easier. And here is how it works. Let's first pick an element. So let's pick one it's down here. So I'm going to pick chromium, which is element 24. So it's right here. And chromium has 24 electrons. So let's do 24 electrons. So we're going to do chromium. We'll do both its electron configuration. So let's do electron configuration, and we'll do its orbital diagram. So electron configuration, we're going to start, and it's got 24 electrons. So it's going to be 1s2, 2s2, 2p6. Okay? And we're going to keep track of the electrons. So right now I've got 2 plus 2. I've got 2 electrons, 2, that's 4, plus 6 is 10, so I can keep going. Now, we go to the third energy level. And every time you move to a new energy level, you go to the S, where there's 2, 3p, 6, that gives us 18 electrons. We've got 6 more. So where do the next electrons go? Well, if you take a look at the periodic table and you look at chromium's electron configuration so far, you can see that here's chromium, right? And it is in the 4th row. So we know that its last electrons are going to go into the 4th energy level. But here's where things get a little interesting. Up to this point, chromium has followed this path. We started with 1 electron, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's, I counted too fast. I threw myself off. Well, you might see here that the S block has 2 columns. 2 electrons in every S sublevel. The P block has 6. Well, a P sublevel will always hold 6 electrons. Here's a D. Guess how many electrons a D holds? If you said 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you are correct. So one way that you can do an electron configuration is just by following the periodic table. So let's go back to the chromium. We're stuck at 3p6. 3p6 means we're in the 3rd row, and we've just added the 18th electron, and we're there. So what's the next electron going to do? Well, just follow the path of the periodic table. Just kind of follow the path. And we're right here. So the 19th electron is going to go into, this is the 4th row. It's S1, so it's going to go into the 4s. And we've got enough to fill the 4s, so 4s2. Right? So 4s2, 4s2. Chromium now has 4 electrons in the D. So you might be tempted to write 4d4. And if you did that, you'd be really, really close to the right answer. Really close. But it turns out, whoops, let me get rid of this. Whoop. So this is 4s2. It turns out that the D sublevel, the D section of the periodic table, that they are always 1 less, that N is 1 less, N is 1 less. So here we're in the 4th energy level. So what that means is, since the D is always 1 less, this chromium will be not 4D, but N is 1 less. So we take N down by 1. Remember, N is the energy level. So it'll be 3D4. Now, let's do the orbital diagram. So we've got 1s, so we're going to have, and we've got the 2s, and then we've got the p, so there are 3 orbitals in the p sublevel. We get to the 3s, and we get to the 3p. Whoops. So here's the 3p. And then we get 4s, so we'll move. Should have done this. There we go. And we can move. Whoops, I can't do that. So then 4s, whoops. And then now we get to 3D, and D has 5 orbitals, and we're going to do Hund's rule. Hund's rule says, remember the bus seat rule says we put our 4 electrons that are in the D, we must put them in separate orbitals before we put 2 together. Okay, so that's a big one, and this is a long video. So in the next video we'll do one more large one, and you should have enough at that point, enough skill to be able to start to work on your SSS and to do some of the larger elements using the periodic table as your guide. Have fun.